G'day, I'm Mark Hoth and welcome to Swift Almanac. Today we're going to add to our members for Swift Almanac app. We're going to create some public keys and save them to the keychain so that we can encrypt all the messages that are sent between our users. So today we're just going to set up our Firebase database, and if you're not quite sure how public key encryption works, we're going to use asymmetric keys, and the purpose of an asymmetric key is it comes in two parts, and the first part is a private key, and that's the one that you keep, and the second one is a public key, and that's the one that everyone else has access to. So if someone wants to send you a message, they use your public key to encrypt their data, and then when you receive it, you're the only person with the private key, and so therefore you're the only person who can decrypt it. And just as an overview, basically a public and a private key are basically really large prime numbers, and so they're hard to guess, and when they multiply together they come up with a unique I don't know, multiplier, and that's the basis of public key encryption. So unless someone else knows what the other multiplier is, they're unable to crack the code, and because they are prime numbers, there are only two that exist apart from the original number and 1. So that's a bit of mathematics for you. You can read up more about it if you so desire. Now we're going to be using 2048-bit keys, and they are computationally complex. We'll get onto more of that later, but it's all handled by the iOS. So let's have a look. Okay, so the first thing we want to do is we want to save this information to our Firebase database, and we already have a database, and so we're going to actually be adding information to it. So in the initial case, it is not going to exist, and the other thing is that because some of this information may be private information, we don't want everyone to have access to it, so we're going to put it in a separate node in the Firebase database so that we can set that node with the authentication permissions to public, so that people can access the public key. Otherwise they wouldn't be able to send messages, you see. So the first thing we want to do is when we're getting back our child info here, and we're in the wrong spot. Let's have a look. Let's find the user. Okay, so we're in the user information, and we've got the user and then the user's ID, which creates every user's unique node, and we're going to add key to the end here, and then we're going to put our key in at the end. So first we want to see if it actually exists. So it's going to be a dictionary, so we're going to go let key dict equal value, and we're going to call it keys, even though there's going to be only one, and we're going to create it as a dictionary, which is going to be string any, and if it doesn't exist, which it won't in the initial case, then we want to create or give it a, what am I doing here? That's better. We want to optionally give it an empty dictionary so that we know that it's not there. So if keydict is empty, we want to create some public keys, and otherwise we're going to call it our pub key string is equal to keydict public key as a string, otherwise it's empty. Okay, so now we need to create this create public key. We'll move down to the bottom of our source file, function create pk, and essentially the way this works is we create a dictionary of attributes which we're going to send off to some iOS calls, and we need to name or tag our key, so it has to be unique. So what we're going to do is we're going to have let tag equals com.swiftalmanac.members, which is our app, and then we're also going to add on the user ID so that it would be unique for every user. And the tag has to be in UTF, so we go .data using .utf8. So that gives us a tag, and then we need these attributes, and you don't need to use RSA encryption. There's a whole swag of elliptical encryptions and all kinds of stuff that you can use. So if you check out the iOS documentation, if you don't want to use RSA, which is what we're going to be using, then you can use whatever is supported by the iOS at any one time. So basically our attributes, there's 4 of them. There's this k, sec, they all pop up. Attribute type, which we're going to set to type as string, and we're going to set that to be k, sec, attribute key type RSA, because we're going to be using an RSA key. And then we're going to have k, sec, attribute key size in bits as a string, which we're going to have as 2048. And then we have this k, sec, private key attributes as a string, and this is a little internal dictionary itself, and that's going to start off k, sec, attree is permanent, so we're going to keep this permanent as a string. It's true, and then the second part is we have to add this tag in, so it's k, sec, attribute application tag as string, and that's equal to our tag. So once we've got this this attributes dictionary, then we're going to need a little error handler. So we've got var error equal to this unmanaged cf error, which is going to be optional, and then because this is all catchable, we need to go do, I've got this new keyboard and I can't hit the tiny little up and down buttons. So okay, so then what we need to do is we go guard let private key equals SecKey create random key, and this is attributes as a CF dictionary, and the error is just ampersand error because we're going to return it. Else and then we just want to throw error dot take retained value as error. It's a bit of a mouthful. Anyway, then that gives us our private key, and then we need to guard let public key, and that is SecKey copy public key from the private key, else again we're going to throw an error. It's going to be exactly the same as that one. So we will copy and paste it. Catch, if we've got an error, we're just going to go print error. So that is it. I should say that up the, where have I done it? Oh no, that's right. So, okay. So let's give us our private key and our public key. They have been created, and then in our myuser.com, what we need to do is we need a couple more properties for our user. We're going to have a public key, which is a SecKey optional, and we're going to have a public private set for a private key, which is a SecKey. And then these keys, if you've opened up a key from your keychain, it'll have like begins here, and then it'll have a swag of numbers and letters and stuff, and then it ends here at the bottom. So it's not a string, it's this special file format, and so we can't save that in Firebase because Firebase only accepts strings. So we need to convert our public key to a string so that we can save it and so that other people can get access to it. So we're going to have a pub, what is it? Pub string struct key, which is a string like that. So then what we want to do in my users is have a function for setting everything. So we're going to have a function called setKeys, which takes a private key of type SecKey and a public key of type SecKey. And then filling in the first ones are pretty easy. It's just self.public key equals public key, and self.private key equals private key. But then we need to convert this public key to a string. So we go if let cf data equals SecKey copy external representation, and then we want to send it the public key, and we need another error. So we'll put the error up here as well. Var error unmanaged. CF error optional. So if we get some data, then we want to let our data be of type data equals CF data as data, and then self.pub string key, which is a string, is just going to be equal to data.base4 encoded string, in fact. Encoded string, and otherwise we're going to print error and okay, so now the other thing we're going to want to do is, if once we've set the key, it's not already in the database because we've just created it basically, so we want to go to my Firebase shared and save the public key. So we need another function over here in Firebase, and we'll do that up near the top here. So we've got load current user, we've got save the current user, and then we've got save public key. So basically it's going to look, oh, there it is there, I've got it from the previous time I did it, so we'll take a copy of that. So our key is going to go to this dictionary, going to call it public key, and we're going to get it from my user shared public key string, and then we just take this line here and add dot child keys dot set value data. We still want to know that user ID isn't empty, so we will just type that in as well, if not empty. Then do that, and if we are saving it, well, we want to save it all. If we're saving our whole user, we want to save it as well. So yes, so now I'm just wondering whether, anyway, just thinking of a possible bug there. Okay, so we've created our key, which was pretty straightforward, and we've saved it in our in memory in our user record, and we've saved a copy of it to our Firebase database. Now, what about the case? Where is it? When we loaded. So if it's dictionary, then we want to create it. What about the case that we want to know whether or not we've already got one? Because what may happen is it's in our oh, and by the way, sorry, just by calling this SecKey create random key, we've passed the tag along. That is already saved in the keychain. There's nothing more that we need to do. It's in the keychain. So so we've got our public and our private key on our device, and we've sent the public key up to the file server. Now, what happens if the file server or the Firebase database like gets corrupted or collapses or whatever happens? We're still going to have our public and private key on our device, but it could be the case that we've got them on our device and it's just lost on Firebase. Now, the reason I point this out is because to use Firebase, you need to have a Google login ID, and I was using a @swiftalmanac.com email address, which was hosted by Google, and so that was fine. However, I now no longer host them with Google, and so even though the database exists somewhere, I can't log into it. So so now I've got a new database for the members app, and so even though this didn't exist, that could happen. But mental note for everyone who's using Firebase: use a Gmail account to log in. Don't just use any email account that Google can authenticate, because you could get trapped like I did. Anyway, I didn't really lose any much. Well, I didn't lose any information that was important, but it's just a pain. Okay, so what we want to do is we want to check to see whether or not when we're about to create our key, we want to check to see if it already exists. So if check PK exists, then we can just say print we already have keys, and then we can just return no, well, we can just return, we don't need to, I suppose. And then we have an else statement for everything else, and so now we just need to write this, check that the public key exists. So function check PK exists, which is obviously going to return a boolean. Probably need a bit more space than that. And we essentially go through a very similar process here. We need to know what this tag is, because that's the reference we've got to the keychain. That's basically the name of our key. And then we need another one of these attributes, dictionaries, that's pretty similar, so that it identifies what our key is, just in case there's two with the same name. But for instance, if we had one key which was for RSA and another key with the same name but for elliptical or something like that, right? So another key standard triple des or whatever it might be, right? So we're actually going to get, we don't get an error, we get an item. So let's get this item, which is going to be a CF type reference, and then we need this query. So we just go we'll call it get query, which again is a string any equal to bang bang, and then we've got k sec class, so the security class as string, and that is k sec class key, because we're after a key. Probably need a comma there. And next in our dictionary we need the k sec attribution tag, so which is basically the name of our key. So we'll put in tag, and then we need to tell what kind of key it is. So it's k sec attribute key type as a string, and that is our RSA attribute, our RSA key type. There it is, key type RSA. And then finally, how do we want to get the return value? And we want to get this returned as a reference. So we go k sec return ref as string, and we set that to be true. So then to do the search, we go let status equal sec item copy matching. So basically what we're doing is we're matching this key description with what's in the keychain. If it's something, if it's there, then it's going to return to get sent to us in this item here. So we're going to go get query as CF dictionary, and the result comes back to us as an item. So was it successful? If status equals error sec success, then we've got our key back. Otherwise, we're going to print error and return. Don't forget, we need to return because we've got have a return value because we've got a Boolean value in here. So we've got some success. So what we need to do is we need to go let private key equals item as SecKey. So that gives us our private key, and then because we've got our private key, we can get our public key guard let public key equals to SecKey, copy public key past the private key, else just gonna print public key error. That's going to return false as well. And if we get to the very end, then we want to, we've got our public key, we've got to put in our user record. So we go my user dot shared dot set keys, and we've got a private key, and we've got the public key, and then finally we need to return true. So let's have a quick look. Compiling away. Oh, it's mirrors. Public key string. Okay, so I called it something else. Pub key string. Pub key string. What else have we got going on here? Use of that's what happens when you copy and paste. We want to set the value equal to key. Pub string key. Self dot pub key string. Almost there. Okay, I'm back. I'm not quite sure what caused that problem, but it could be the fact that I've got two projects with the same name. So anyway, so as you can see from our data record, we have no keys. So we'll run the project. It all runs fine for the first time, and it says we already have keys. That's because it's already run it once. But so the keys there were still on the iPhone, and then if we look back at our database, the public key has now been loaded up. So that's it for this lesson. That's how to create public keys. Next lesson, we're going to do some interfacey stuff to create the messages window, because currently it just says coming soon. So we'll create this window, and then in the lesson after that we'll start sending messages and encrypting the data. So yeah, hopefully you've learned something, and now's the right time to like, and if you haven't already, subscribe to the channel, because 2 great new lessons are coming up real soon to finish off our app, and then we're going to move on to things like encrypt and stripe. So lots of cool things coming up in the future. Thanks very much for watching, and we'll see you soon. Cheers.